Thank you all for taking the time to come and listen to INCeNSE, about INCeNSE and also about our startup journey. Special thanks to some of our industry participants and apologies for getting delayed. Can you straight away move to the agenda? Next slide. Can I have the slide? This is the one. Can you move? Yes. That's a video about INCeNSE. I think some of you have listened. Yeah. So this is the agenda. We will, first of all, welcome all of you. And after a quick introduction by Vasu, we will move to the startup presentations. Vasu.
Okay.
There you go.
I welcome Dr. Kaur and the team from the government of Karnataka here. All I'll say is, given from where we started off, it's a pleasure to see you all here. And I was just telling her, as I told you in the morning, that feedback is most welcome. And I happened to be in IIT Madras for a conference over the last 4 days. The good thing was the conference was in their research park. It was an eye-opener. And so I know what is the gap between where they are and where we need to be. And those are some ideas that we hope to implement in the next phase. So with that, thank you. And Prosenjit, please go ahead. I thought, oh my God, okay. Right.
We will just move to the presentations. So I think Harish is going first. Yeah.
Check. Yeah. I think we're good. Yeah, no problem. Yeah, sure. Great, thank you. I'm Harish. So in the interest of time, we'll just skip ahead. So our startup is called Agnet Semiconductors, and we are India's first gallium nitride technology startup, and I hope to convince you why that matters. So if you take a look at where, two major trends in the world today, it's in the way that we communicate wirelessly and the way that we consume electrical energy. At least this is what is playing out in the electronic space. And gallium nitride will have a key role to play in both of those areas. So let me explain how. So if you take a look at where we were over the last 20 years, right? So in terms of wireless communication, we went all the way from 2G base stations to 3G to 4G. Right? And in terms of power conversion, we used to all have chargers for our consumer electronics, which used to be slow chargers, if I can call them that. So important thing to note is that all of these by silicon-based semiconductor materials. So when I say semiconductors, people normally tend to think of silicon, and silicon electronics have indeed seeded all of these revolutions that you see here. However, in the next 20 years, so we're going to see the shift to 5G, 6G, and beyond in terms of wireless communication technologies. We're going to see a shift to next generation radars in terms of wireless transmission. There's going to be a whole host of IoT-based applications, all of which are going to consume quite a bit of data. And interestingly, in the power conversion space, we are going to move to, let's say, full EV adoption in the next 10 years or so. And we need technologies like fast charging, wireless charging in order to enable these revolutions. What's also important to remember is that this is not a business as usual transition. So the entire electronic systems in all of these application spaces are being redesigned to accommodate these trends. So, and also important to remember is that the semiconductor material that is powering most of these revolutions is called gallium nitride. It's not based on silicon anymore. Key components are now moving to gallium nitride-based electronics. And these are all fairly big worldwide opportunities, as well as an India-specific piece. So that's the opportunity that Agnet aims to tap. So what is it exactly that we do? So we make gallium nitride materials and devices, both for radio frequency as well as power electronic systems. So here's one of the components that we make. This is a gallium nitride radio frequency. Useful in applications like GaN for 5G and GaN for radars. We're actually in the process of putting something into a radar as we speak. We also have, this is, for example, a gallium nitride-based power switch. And this kind of power switch is used in GaN for power converters, let's say, and for two-wheeler fast charging. In fact, any kind of fast chargers that you have today for your cell phones, they all use a gallium nitride-based chip on it. So all of this is important. Why? Because our electronics import bill will exceed our oil import bill in 2023. I think if oil hadn't hit $100 a barrel, we'll probably be there already. So this is the gap that we aim to plug, right? So even though we have, and as part of India, we have a very strong design ecosystem in all of these areas, whether it's telecom, power conversion, etc. There is no local ecosystem of components which are seeding these players, and that's the gap that Agnet aims to. So we are an interdisciplinary team of scientists. Our origin is in IISc. We're a spin-off from here. So we're a team of material scientists, semiconductor process engineers, device technologists, and this is the kind of deep expertise and wide-ranging expertise that you need in order to actually commercialize technology in this space. And it's a very long drawn-out process also. So just a brief recap of our journey. So we started in January 2021, and we were at this proof of concept TRL stage. So it was a team of 2 of us who were sitting around in the INCeNSE office. And thankfully, we also were part of a couple of accelerators which really helped us in terms of commercialization, especially. In June 2022, we had working prototypes, and team size was 5. We also happened to win Elevate in 2022, so that's also been part of our journey. So in December 2023, where I'm standing now, so we have customer visibility and product refinement is ongoing. We've also recently won the IDEX grant from the Ministry of Defense, so where we are developing gallium nitride solutions which can go into defense electronics. So that gives us a strong visibility of customers for the products that we are making. So by April 2025, we hope to be revenue positive, and the team size should be around 14 at that point of time. So how is it that INCeNSE has helped us in our journey here? So what we do is extremely technology intensive, as you can imagine. So in terms of the technology, baseline technology itself, which came from IISc, so that kind of IP was made available to us as part of our incubation. And we also have facility access is absolutely crucial. Both the facilities, for example, that you saw, are absolutely essential for us to carry out our own work, because we are one of the few semiconductor manufacturing startups in the country. This is also a very, very talent-intensive process, right? So we need extremely good engineering and science talent, as well as technical, as well as business mentorship, right? And being in the IISc ecosystem enables us to tap into that. Of course, the other thing is that given that we are a bunch of technologists, we also need extensive business mentorship, which is also made available as part of INCeNSE. And more to think about it, we are all deep technologies, so we need a strong and robust IP strategy, as well as how to monetize the IP that we generate. So in terms of ecosystem connects, of course, being in IISc, being part of the INCeNSE ecosystem, we've had access to customers, who are willing to talk to us, having access to investors who are willing to invest, as well as partners in order to take the technology out into the real world, which is very essential. Right. So in terms of next steps, so here's where we are. We are the first prototype sort of stage, and we'll get to a field test and PO sort of a stage. We need a few million USD for us to complete this journey. So if you're interested in funding Agnet, please come and talk to me. Why all of this is important, even from a larger ecosystem perspective, is that each dollar of semiconductor revenue creates about 10 times that amount in the larger system level ecosystem. And each job in the semiconductor industry in turn leads to about 6 indirect jobs in the economy. So this is pretty important. And what we're looking for now is patient capital and value chain connects in terms of getting our technology out into the real world. Thank you.
Hello. A very pleasant morning to one and all. My name is Neeraj. I'm a mechanical engineer. I have previously worked at Unilever and GE Healthcare. And right now, I run this manufacturing innovation company named Mucron Technologies Private Limited. We are a startup based in Belgavi, but we also operate here in Bangalore at Rajarajainagar. So what we do is that we specialize in the micro machining of glass as a substrate, and we specifically cater to the microfluidic device industry and the MEMS packaging industry. So let me begin by telling you a use case. Now I'm quite certain every individual sitting here has visited a laboratory or a diagnostic laboratory to do some form of maybe blood testing. Now what happens there generally is a lab technician takes a syringe, collects some of your blood, and depending on what type of test you're doing, maybe your results are given to you in couple of hours to maybe couple of days. Now all this can be done more real time at a much more convenient at a much more convenience to the consumer, and more importantly at lower costs using microfluidic devices such as these. In the most general sense, microfluidics is the study and the manipulation of fluid flow at a very micro domain. The applications in the life sciences domain include point of care diagnostics, lab on a chip devices, organ on a chip devices, among many other exciting avenues. And the market driving forces for this particular sector is the miniaturization of a lot of lab processes in the diagnostic industry. We estimate that this market is going to be roughly about $15 billion by 2026 globally, and this is where we intend to tap it. Now I'm also certain that most of you have heard this story quite multiple times at various events, exhibitions, academia and other places. But the real question that needs to be asked and answered is why have why have the microfluidic devices not been very successful in the market today? Why is the market not flooded with all these devices with various applications? And if you dig deeper into it, you'll arrive at these two problems that the industry is facing. The first is the time it takes for prototyping and product development of these devices, and the second is the high cost of product development. And as a company, we are specifically solving these two problems for our customers by developing a solution which is an alternative manufacturing technology that can be utilized as a rapid prototyping tool for a wide range of microfluidic devices. This is the image of our current stage of our prototype. It's at TRL level 6. In fact, we are utilizing this particular setup to fulfill few of our customer needs and orders on a service-based model. These are the USPs of our product. It is rapid prototyping, low cost of fabrication, it is material agnostic in nature, and more importantly, it is a maskless process. These are few of our capabilities. These are some of the microfluidic magnified images of our devices, dies as well as through holes that we have done for our customers. Our capability right now, we offer about 50 microns minimum feature size on these devices. This is the team. We have Professor Jinka Ranganayakalu, who is our technical head, technical mentor. The other co-founder is my father, Mr. Ganpati Bagi, and truly the backbone of this company are these four bright engineers, Yashwant, Mohan, Darshan as well as Varun. Coming to the role of INCeNSE, INCeNSE has helped us with the access to the characterization facility at the nanoscience department. Additionally, INCeNSE has played a pivotal role for us to gather customers as well as industry networking, and more importantly, their mentorship has also been very valuable to us. This is our roadmap at Q3 2023, that is roughly about right now. We have 7 paying customers on our platform. We specifically target the Indian market, and our team size is about 6. In 27 months from now, we aim to at least impact 200 customers globally and increase our team size to about 20. And to do all this, we will certainly require help with investor connects, industry networking and customer connects, as well as the opportunity to exhibit at various different events. This is the last slide from my end, few accomplishments. The one that we are particularly proud of is the Techceleration Beyond Bengaluru program, which was organized at Hubli last year, and we are one of the winners of that particular program. Also, we are one of the winners of the Elevate 2023 program. So with this, I conclude my presentation. Thank you very much.
So hi everyone, my name is Neha Jahan, and it's a real pleasure to talk to you about our journey from material discovery to startup. So let me just introduce our team first. So we are a team of 5 people, and we are a unique team because we come from diverse background, from chemistry to material sciences, physics, electrical engineering, and biomedical sciences. So let me just give you an overview about the flexible electronics or the printed electronics. So the silicon, as you all know, that is ruling the entire world. And when you talk about the integrated circuits, so we have end up getting a very high and powerful integrated circuits, and of course the highly efficient solar cell power panels. But just imagine when you try to build up these kind of circuits, can you really make on flexible substrates? Can you coat those electrically conductive inks on windows? You have these flexible screens, biomedical devices which can be just wrapped around, building integrated with photovoltaics, and just wrapped around phones, like you can just put it on your hand and take it anywhere you want. The flexible photovoltaic screens, or even the transparent toasters. So with the current technology, there's a huge drawback, is like it can't be bended or folded. And of course, the manufacturing cost is too high. So this is where we pitch in. So we have a cumulative experience of more than 30 years, And we actually process chemistry for synthesizing molecular semiconductors. Now the question comes whether we do have any industry or any company related to these kind of materials. Of course, the answer is yes. We do have many companies across the world, but they do have some drawbacks in terms of high costs, reliability, inconsistent device performance, and customization. So this is here again we pitch in. So we are the first in India who actually synthesize highly electronic grade materials towards printed electronics with customized solutions. So the opportunities, we offer electronic grade molecular semiconductors, tunable band gap, photoactive polymers, photoresist, photoactive molecules, specially designed for these specific application, from printable solar cells to photodetectors, redox flow batteries, electrochromic windows. So our goal is actually to create a niche field in printable electronics through indigenous supply of semiconductor grade organic semiconductors. And we do provide services like the product demonstration, customized synthesis, like the problems which are already there in the market through our tech transfer techniques. And this is the process that we follow. And we do have international publications and patents to support our IP. So just to give an overview, so they are like quite easy to process. You just need to spray coat or use a standard printer technique to make any kind of devices with these kind of materials. So just to give an example, if you compare with the standard photodiode, which is a silicon Hamamatsu photodiode here, you can see this is a performance merit. And this is a key element when you talk about oximeter. I think everyone must be aware of that. So because this is a light sensor actually. And when we start building up, making use of our materials, and we made a photodetector out of it, it showed a highly comparable performance. You can see here it's almost comparable to silicon. Why not to go for flexible oximeter, which will be quite useful for hostile patients or patients who are actually not able to put out in. So the next is like, let me just give you another proof of concept study that we have demonstrated in our lab. It's the electrochromic devices. So these are the devices which are capable enough to change their color when you apply a bias. So you can see a change in color happening, quite useful for electrochromic windows like the smart windows in aircrafts. So you just need to code them on windows and you can see a color change happening. Apart from that, there's one more advantage, that they actually operate at very low bias voltage, also consume very less energy compared to the current market available. And they also provide filtration effect, so you can actually cut off UV or NIR lights through these particular windows. Moving ahead, so the role of INCeNSE. So we are like quite fortunate and lucky enough to get incorporated in INCeNSE, as it provides the nanoscale fabrication technique measurements, the material characterization facilities. Apart from that, it's not only allowing us to access the current state-of-the-art facilities like in these areas, but also giving us the business mentorship, which is highly useful, to find opportunities like funding opportunities or finding investors. And of course, to fill up the gap between lab to market. So what next? So where we are actually right now, so we have almost set up things. We have our polymer library recipes optimized with the proof of concept studies. Now we are at this stage. We are actually, our immediate customers will be the academic institutes as well as the companies, the R&D sections. And we do expect our first revenue to be generated by the end of third year. So we are also looking for research interns. If anybody wants to connect with us, please write to us. And the last and not the least, so we are actually looking for funding opportunities to scale up our product quantity, and also the entrepreneurship in residence. So right now we are like partially working for the startup, but we'll really appreciate if we get some EIR sort of applicability so that we can go to full time. And that's all. Thank you so much for your time. We'll be happy to have any questions.
Hi, my name is Aditya. I am one of the co-founders of the startup ABX3 PV, and I'm also a faculty at CeNSE. I'm substituting for one of our speakers. So I'm an electronics engineer by training and also a physicist by training. And today I'll be talking about a startup which works on perovskite solar cell technology development. we are one of the first end-to-end solution provider who can develop the perovskite technology starting from materials all the way up to the final packaged product. So what are we trying to do here in our company? So we're basically trying to participate in the transition from fossil fuel based ecosystem to power energy to the renewable ecosystem. So why perovskite solar cell technology? So here you're talking about comparing established first generation silicon solar cell technology with a upcoming third generation perovskite solar cells. So when you talk about silicon solar cells, you basically have to import starting from the raw material to technology and the equipment that you use for manufacturing. And that basically means that your costs are obviously going to be higher as compared to what a manufacturer can do, say, in China. And also you're limited with the active area, so that's limited to the wafer size that you produce. And also additionally, it's not suitable for any upcoming applications like indoor based photovoltaics and agrivoltaics. Then what about the third generation solar cells? So that's where we try to solve the shortcomings of the first generation solar cells. So in perovskites, you basically have the raw materials that are locally available in India. Through our startup, we are actually indigenously developing both the technology as well as the equipment, and I'll highlight that a bit later why. That ensures low cost manufacturing and it's scalable, so we are not limited to the wafer sizes. And these technologies are ideal for indoor photovoltaics, and also they basically have a figure of merit which is having the highest power conversion efficiency per unit weight. So I'll tell you where it's useful later. So looking at the future, so if you look at perovskite technology, it's basically having the lowest energy payback time compared to any established technology that exists today. And if you look at the future roadmap where the solar industry would be going globally, you basically have saturated, come to the practical limits for all technologies, even including perovskite for that matter. So if you go forward, you will have to go in the tandem solar cell route. So you have to combine two technologies and get more efficiency. So this is where basically we are trying to develop perovskite silicon tandem so as to integrate into the existing silicon manufacturing industry, which will give us the maximum benefits. So what are the opportunities? So at our startup, we are making single junction solar cells, and we are also making tandem solar cells with silicon. And we are sort of targeting applications that include grid power. We are targeting applications that need flexibility or mobility, and we are targeting the next generation applications. So on the grid power, you basically have your normal grid based solar cells that we are targeting and flexible solar cells. In the mobility sector, where we are targeting EVs or say flying drones, where we have the lightweight solar cells powering those drones. And we have the futuristic applications where we use the real estate, vertical real estate in any building or any greenhouse sort of architecture to produce power and powering IoT devices. So in terms of the market size, the global market size for each of these segments is huge. I mean, it runs into hundreds or thousands of billions of dollars. And in terms of Indian market size, you're talking about several billions of dollars already. And this is the market size we are going to tap into. So role of INCeNSE, we basically have incubated here because it provides us a one-stop shop for doing the whole end-to-end product development. And it also provides us good leads of funding and mentorship. And because of the location, we actually have the best case scenario to attract skilled manpower. So who are we? We sort of are, these are the founder team. So we basically, it's myself and Sushoban who are the experts in material and spectroscopy and devices. We have an expert, Dr. Lakshman Gowda, in scaling up this technology. We have a packaging technology expert in the form of Professor Praveen Ramamurthy. And we have an industry interface expert in the form of Dr. Gangadhar Rao. So overall, we are covering all the segments that we need for a startup to succeed. And beyond that, we are backed up by a growing patent portfolio, and we are sort of having a very good proven research track record. That's our core strength. And the state-of-the-art performance PV devices. So we are the best in the world as well, and even in India. So I'll show you a few highlights. So we have started with the indigenous development of the manufacturing technology. This is very important because recently China has banned the export of silicon manufacturing technology to India. So all the upcoming industries, they'll face problems. So we have to be self-reliant, and this is where our efforts come in. And these are all sort of designed and developed in Bangalore. So we move on to the fabrication part. This is what we have been doing at the incubator over the last few months of our incubation. And we are currently developing mini modules of this scale. So one of the modules I can show you is A4 size here. So this is a flexible module I have. So what next? So this is where most of our research is focused on in the research laboratories, and we are moving on to the larger scale. So in terms of the milestones, lab scale, we are currently the best in India and even comparable to the state of the art in the world. We are currently working on prototype as part of our incubation at INCeNSE, and we would like to go towards the module development in the coming time. So the roadmap of our company currently is, so we have developed our equipments to do the manufacturing, and we have made a small area prototypes. This year, just few months ago, we have incorporated a startup and also incubated a startup here and started working on the prototype development. So the coming year, we basically will be developing a prototype which is of A4 size, the size which I just showed you. Sorry. So with that prototype, we'll actually go for our first seed fund round, and then we'll work on the silicon perovskite tandem to address the current existing industry. So in 25, we plan to license our technology and start the revenue generation. 26, achieving the break-even point. So I'll thank you for listening, and these are the aspects which we are looking forward to. So as a faculty, I am looking forward to developing a facility here which can support such thin film photovoltaic startups and other aspects here. Thank you.
Good morning, ladies and gentlemen. I'm thrilled to introduce Meerkat's World, a revolutionary, committed to revolutionary longevity of the devices. We at Meerkats, not only emphasis on the energy efficiency, reducing e-waste and sustainable solutions. But energy efficiency is not just a feature, but it is a fundamental technology of our services. Our dedication in reducing the e-waste is unwavering. So by extending by optimizing the performance of the devices, we are saving the energy and contributing to a sustainable and eco-friendly future. Sustainability is at the heart of whatever we do. So by integrating the nanotechnology solutions, we promote the more environmentally friendly solutions. The mastermind of this innovative nanotechnology is our esteemed Chief Scientific Officer, Dr. Professor S.K. Chakravarti. We also have the industry experts as our advisors in different segments from B2G, sales, finance, collaboration, and technology. We have an in-house team of 12. So what is the problem which we are solving? We are looking at the operational life of the computers, which is just 3 to 5 years. Also the productivity loss because of the fast aging of the computers, and also we look at the power inefficiency because of the slow processing of the units. So this is our core area where we thought we should be looking at. The rapid aging is mainly because of one material which degrades, is the thermal interface material, and we have concentrated on the thermal interface material degradation problem. So what did we do for that? So we have pioneered an ingenious solution based on nanotechnology, a metallic thermal interface material. So this thermal interface material is designed to combat the fast aging of the computer. The invention revolves around the nanotechnology, where millions of nanocylinders align together vertically to provide the metallic conduit for heat transfer. And this particular chip which we have invented not only provides the electronic and phonon conduction, but it also reduces the boundary resistance. It also increases the heat dissipation area by 6 times. So we are addressing the problem of degradation of the thermal interface material, which causes in the computer, and which because of which aging of the computer happens. We have named this particular invention as Chakravardhan 22. We call it CV22. It is truly made in India. So let's delve into the opportunities. Meerkats has done extensive research, and we find that the total addressable market is in India is 45 million. Out of that, the realistic portion of our market to reach out with our solution is the quarter of it. With the extensive corroborated data which we have collected, we have estimated the energy savings of up to 86 million units every year with the deployment of our chip with the deployment in 1 million chip in the computers. Sorry. So let's talk about the tractions. With our inventions, we have undergone in situ testing over 2,900 laptops, and the results, yes, a staggering 90% feedbacks, positive feedbacks received, improving the performances. Also, we have noticed, the users and organizations have also confirmed the tangible benefits by using our product, that the increased power efficiency of their computers, and also the increased power consumption. So here I would like to highlight the critical part of having the facility which we required at micro and nano characterization facility is our current limitation is a black box testing, which restricts ourselves to do further research, in-depth research of our services, and it also hindering our progress to reach up to the level of critical unit level of understanding. So MNCF equipment, MNCF lab facility is paramount, and access to this lab will not only fill the void, but it will also reduce our reliance on the external facilities. So the next steps we are looking at is we are looking at mainly 2 pivotal areas. We are planning to focus on 2 pivotal areas, is the implementation of our sales strategies and also advancement of our services. So over next 6 months, over next 4 months, in fact, we are planning to do further research on the and do the proof of concept for the cold plate technology. We will also do the further enhancement and perfecting the potting material. We are planning to do the proof of concept in 6 months for the potting material as well. So as we move forward, we are enthusiastic about the opportunities ahead and the impact of our industry, the impact of our innovation have on the industry. Thank you.
Good afternoon. My name is Lakshmi Vaidyanathan. I am the founder and managing director of Jair Falcon IntelliEdge Solutions India Private Limited. I'm very happy that we've recently been selected for incubation here at CeNSE, and I thank you for this opportunity. I am an IISc electrical engineering alumnus, and I have an industry experience of over 29 years. So the topic that we are working on is on intelligent edge devices. Basically, we are looking at solving Industry 4.0 problems through our automation solutions. Everyone is familiar with IT applications, things like payroll, recruitment, and attendance management, where you sit in front of a computer, internet-connected computer, and you can get the status in one shot. But operational technology components, that is the status of a production line or a machine status, is not visible. And today, to be able to get that visibility, you need sensor-based technology. Additionally, you also have mobility components, material delivery trucks, a pallet vehicle which is moving around. And you need to get a holistic view of all of these things in order to be able to plan and coordinate the data and manage all of this in a single view if you want to look at Industry 4.0. So bridging the gap between what is there in IT and bringing all of these components together requires IoT gateways with real-time sensor data for the data aggregation. So the solution for this data aggregation is IoT gateways. And the IoT gateway market is a rapidly growing one. It is growing currently at a rate of cumulative annual growth rate of over 13%, expected to be a $3.4 billion market very soon worldwide. And IoT is going to impact all our lives in different ways, whether it is energy, whether it is agriculture, education, healthcare, whichever one. But the most important impact for a country like India is the impact on industries and manufacturing. India will be the largest consumer of IoT devices in the next 5 years, is the prediction that NASSCOM has put in. And the government of India is targeting that Industry 4.0 based manufacturing should contribute to a quarter of India's GDP by the year 2026. Now, with these large visions, it's extremely important for us to have our made in India electronic devices, and we need to have the data of our machines and environment with us here in India. So this is where the IoT work that we are working on is important. What we are building is an end-to-end solution where we build the indigenous hardware, IoT hardware, the intelligence within that hardware, which is the software, and the device management platform, all of which is customizable for our requirements. And this is something that we have a patent on right now. The target that we are looking at accomplishing is providing those long-term sustainability and cost savings for the industry, finding ways by which we can do preventive maintenance and predictive analytics. So what our hardware can actually integrate is a variety of different sensors. And why is this important? What are the kind of applications that matter? I think everybody is familiar with vehicle and logistics, vehicle tracking and logistics, where you get the data about where a vehicle is, and it makes a lot of difference to your logistics planning. But going beyond that, there are many other sensor requirements which we have. We have a number of supply chain problems where humidity is a problem for us. Can we track this with different sensor-based devices? Can we improve different kinds of industrial automation with fuel monitoring, with vibration monitoring? And there's this need for very large number of new sensors. We need radar, sonar-based sensors, and data to the cloud from all of these sensors. We need light sensors. So this is the area that we want to work on, where we have a roadmap for our company, but the most critical summarized view of the roadmap that I can give you is that we'd like to be the top cloud analytics enabling IoT gateway provider for sensors which are manufactured in India. And that's what our device we'd like to be able to integrate. So we are different from the other companies in CeNSE. We are an electronics and hardware software company. But there's a very strong synergy because CeNSE has a vision for and is working on sensors for India. And there is a requirement for a variety of new sensors, NPK sensors. We can list out a number of new sensors, and I hope that we'll have some of those other companies which are working on these. And what we see is a synergy between those sensors which are there and our ability to bring that sensor to life through bringing the data to cloud. So we are looking for strategic partnerships. We are also looking for field trial opportunities and industry connect, and we'd like to have support for manufacturing. So we're a small team of part-time and full-timers working in a variety of areas. We are 3 founders, and I know it looks large, right? Yeah. But there are a lot of part-timers there. My co-founder Radha is here, and she works on the area of marketing. My other co-founder Narayan Swami is a faculty at IIT Madras. So this is my company. Thank you for having me.
That was to just work as a teaser. We don't have time for listening to all the good things and the great things and the hard work that these startups are putting up. But still, we want to give a teaser. Special thanks to some of the industry representatives. We have from Applied, we have from other Ankur Capital and many others. So please do, not only to these startups that we have here, there are also other startups, whoever is in white shirt, they're all the startup owners. Now I request our chief guest, Dr. Kaur, to give an address. To those of you who don't know her, she is the secretary in the IT department. It's long one, Department of Electronics, Information Technology, Biotechnology, and Science and Technology. It's a wide span of activities that she's overseeing. And she is very experienced in the administrative service. She joined the service in 2001 batch. So we are really grateful for all the support that we get from the government of Karnataka through all the representatives that we have here. Darshan, you may want to say hello. And Champa, Parnika, and Vijay Lakshmi, and also we have Chetan from KDM. So it's important that these people support us so that we are able to do events like this and get all of you together. With that introduction, I will request Dr. Kaur.
Good morning, everyone. It's a pleasure to be here this morning. It was a long pending visit. I joined the department about 3.5 months back, and I have been wanting to visit IISc and all the collaborations that we have with various institutions within IISc. Of course, because of me, we started a little late, and I'm sorry we had to rush you through the entire proceedings. But I must acknowledge that it has been a tremendous experience being here today, a tremendous learning experience, and also it's given me a lot of confidence in the kind of work that we are doing, and I'm so happy that this collaboration was done. We in government, of course, we react to certain inputs which come from various stakeholders in the ecosystem, and some initiatives are taken, some of them pan out very well, while the others may not do as well. But especially in this area, in the current department where I am, ITBT, a lot of our collaborations are work in progress. While we start out with a certain vision and certain understanding of the ecosystem, as we go, we try and improve on what we have done. So this collaboration or INCeNSE has been there for about 5+ years now. It's almost actually the 6th year is coming to an end. And on the way, I believe there have been a lot of learnings. And now, as we are at the hem of starting our new association, we would be again, getting into at least a 5-year kind of collaboration. We would like to work on what has been the learnings from the first instance in the 1.0, and we would like to strengthen this collaboration. I have interacted with Mr. Vasu and with Tulsi and the team, and I've also heard all of you guys are doing really tremendous work, really proud of it. We will certainly try and address the issues that have been raised today. I completely understand that this kind of deep tech work does require a longer incubation. It is not something like IT and ITAS services, where many of which actually in a year's incubation you can come out with results. So certainly we will look at a longer period of incubation. The other thing is, it is true for all industries, but with industries which have a longer incubation, is to get investor connect, because many investors would like to see quick gains and would like to invest in things which would mature very quickly. but deep tech and biotech and certain areas within even in IT are such that where incubation is longer, but once you succeed, the results can be tremendous. And today, even the VC ecosystem has matured quite a bit. They are not looking only at valuations; they are also looking at the value add. So some of them are very keen on investing in products, in services that would have a deep impact on society. So they are not, I mean, large number of VCs and a lot of VCs which have originated from Bangalore, many serial entrepreneurs who have now become venture capitalists. They do understand the pains of the sector, and they understand how everything cannot be just guided by valuation, and are not looking at quick results. So it would be our effort and endeavor to connect you with such VCs and see that they are able to see the value in investing in some of the startups that are being incubated over here. We'll certainly work on that. The other thing some of you mentioned was about visibility and being able to present and participate in events. Certainly that is another priority of the department. We work in close collaboration with industry leaders, with other stakeholders in the ecosystem. We ourselves run a couple of events which have over the years now become fairly well recognized at a global level. We are also doing market connects and visibility programs for specifically tailored for certain startups. We have recently introduced a market access program with our Global Innovation Alliance partners. We have partnerships and MOUs with about 35 countries, which the state of Karnataka has directly entered into MOUs. So we are, through our GIA Connect, we are trying to organize market access programs where we take startups from a specific area. We don't keep it very open-ended and general, because then the interaction is not as fruitful. And then we connect them to the right people in the ecosystem in the given country. So we've just started that. We've had our first batch which went to UAE. We will be shortly taking another batch to Belgium and to many other countries, depending upon what is the requirement and which market would be the most suited for their products, which would be the most suited for getting good industry connects. So we are working on it, and I'm sure we could actually look at some of the startups which are incubated here. And if there is a specific requirement that you have, you can also reach out to us so that we can start working around it and find the right people with whom we can connect you. Of course, Elevate and all have been programs which are very successful. They've been running successfully over the years. There was a request that we should have a separate vertical for deep tech within Elevate. We'll consider. I am not very sure. I would not like to make a commitment on something that I have not understood that well. But I will certainly take it as a takeaway, and we will work on it. If it is possible, we'll do something around that as well. Other issues which have been raised regarding infrastructure, increasing the amount of support and all, I would say that I am certainly committed. We will make our best efforts. I am not sure how much we would be able to meet the expectation, because there are, as you know, no matter how much money we put in, the demands are always more than what the supply is. We will try and balance that out, but certainly some of the interventions which have been done by the department over the years are very successful. This is one of them, and certainly we will work on it and we will strengthen and take it forward. Just to close, I think it's been a great morning and I've enjoyed every bit of it. I will again come back. I would like to interact and understand more. I come from humanities background, but I'm trying my best to learn and understand, and we'll see that how we can further strengthen and take this forward. Thank you so much for having me, and sorry about the delay today. Thanks.
This brings us to the end of the event. I would like to thank Dr. Kaur and the team from GOK for participating in this event. I would like to thank all the industry participants and investors to come to these events, and I will encourage them to discuss with our startups. And finally, but not the least, I would like to thank our startups who have worked so hard to be here today. And with this, I will like to close the event. And thank you. Thank you.
Just a small note, the lunch is served in CeNSE parking, and we have these colored badges. We have, as I said, students, we have startups, we have industry, and we have a couple of government representatives, I guess they stay back. So please feel free to network. The purpose is, as I said, this is a teaser. The real value comes from talking to each other. Thank you. There is a photo session outside for 2 minutes. We'll just take a photo in the space next to the